Avogadro's hypothesis, or Tuesday, Avogadro's hypothesis, which basically says that all gas samples that have the same temperature, pressure, and number of particles occupy the same volume. Doesn't matter which gas it is. Okay? And we call this STP, standard temperature and pressure. It will give a volume of 22.4 liters. Now, I also said later on that it was changed slightly. Only certain organizations changed it. Some changed it to 22.7 because they changed the pressure. Others did not change. They used the original. So we're just going to use for all our calculations 22.4. Okay? That seems to be the consensus. Standard temperature is 0 degrees Celsius or 273 Kelvin. Standard pressure, 101.3 kilopascals, or it's just 1 atmosphere, what we feel right now. Okay? Why is this important? Why do you need to know this stuff? These pieces of information. What happens if you change the temperature of a gas? What happens to the gas? What happens to the particles when you change temperature? They either expand if you heat them up, or they get smaller, more condensed if you cool them down, right? Solids are condensed. If you heat up ice, it melts into a liquid. The particles are further apart. Okay? So it's important to know this when you're doing experiments. 2 conversion factors. If you're going from moles to liters, 22.4 liters per mole. And if you're going from liters to moles, it's 1 mole is 22.4 liters. Remember, these are for gases, not liquids. Okay? Gases. And then we just started doing conversions. So let's finish off these conversions because we're going to start multi-step conversions today. So how many moles of gas are contained in a balloon with a volume of 10 liters at STP? What goes in the first box? What piece of information are you given? 10 liters. So 10.0 liters of our gas. We don't even know what the gas is. We don't actually care because all the gases have the same volume. I want to know how many moles. So what's the conversion factor? What unit do I need here in this bottom box? You need liters, right? Because you want the liters to cancel. What's our conversion factor? We have 2 of them. We're going to use this one because this has liters in the denominator. So we get 1 mole is 22.4 liters. Divide them, and you should get 0.46 moles of whatever gas it is. Okay. Next one. We're adding one more sort of wrinkle to this. 550 mils of H2 gas. How many moles is that? What's the problem? Not the problem. What's the change here? It's milliliters. All right. So you have to watch the units. The units matter massively. So we have 550 mils of H2. I need to get rid of milliliters. Anybody remember the conversion of milliliters to liters? There's 1,000 milliliters per 1 liter. Pen not working. So milliliters cancels. So now our units are liters. How do I go from liters to moles? What's the conversion? .4 liters in 1 mole. So 1 mole of H2 is 22.4 liters. Multiply across the top, you get 500. Multiply, the bottom. 22 times 1,000 is 22,400. And then divide top and bottom, and you should get. How many sig figs in your answer? 2, right? Because the first one had 2. 0.025 moles of H2. All right. Last one before I give you a couple on your own. Determine the number of atoms found in 4.2 moles of chlorine gas at STP. So we're given 4.2 moles of chlorine gas. Remember, chlorine is a Brinkelhoff gas. Chlorine, fluorine, bromine, oxygen, hydrogen. At STP, so 4.2 moles of CO2. I want to know how many atoms. So what am I going to do here? What conversion factor am I going to use? We're talking about atoms and moles. Avogadro's number. What's Avogadro's? That's right here. That's Avogadro's number. I've got moles. Do I want moles in the top or the bottom of the next box? Bottom. So I'm going to use this one, right? 6.02 times 10 to the 23 particles is 1 mole. Those particles of chlorine gas. Let's write particles of Cl2 in 1 mole of Cl2. So moles cancel. Now we have particles of Cl2, but I don't want particles of Cl2. I want atoms. So what do I have to do? How many atoms are in a chlorine gas molecule? 2. So that means there are 1, I could say particle or molecule of Cl2 has 2 atoms of Cl. So you have to multiply your answer by 2. How many sig figs in our final answer? 2, right? Because of that. So it should be 5.1 times 10 to the 24 chlorine atoms. That seem right? So these are the exact same thing we did in the previous unit. We're just using different words now. But the idea of unit conversions and stuff canceling, it's all about lining up your units to cancel. That's it. Then you multiply everything in the top, you multiply everything in the bottom, and then divide your answer. And there you go. Okay? The next step, what we're going to do today is we're going to start to do multi-step, where these, like this is a multi-step, but they can be really, really big. And that's into the next unit, etc. So I need you to do those questions in Hebden. I'll give you some time. Hebdens are over there. Page 83, questions 11 and 12. And then we'll move on to multi-step questions, and I'll outline what your quiz will look like tomorrow.